solid H of f of x, y, z is the probability that capital X, comma, capital Y, comma, capital Z is inside H.
So the idea is that X, Y, and Z are random variables, so they do take on values, but not like one. They can take on like a range of values, and they do so with probability. So the point X, Y, Z, while we don't know where it is, we can make good guesses about where it is by computing triple integrals over portions of space where we're guessing that the point lives of its probability density function, and then getting back the likelihood that the point's actually there. So, for instance,
So we're evaluating a random point
yeah,
to decide. Okay.
I mean, these to be like capital letters.
There you go, this guy on the computer said.
Yeah, feel free to.
I was actually just gonna ask you if it was like too late to turn this in.
no, I'm here. Okay. So in your problem that you have, we use this first property for part A and the second property for part B.
Okay, that was
Part-
so
okay,
that
good.
much
All right, great.
I picked up that.
Got that, okay, out of the way.
So in your example, I think
So we'll evaluate this CXZ over whatever quantity x squared plus y squared plus z squared to find C. Okay.
So I think it's equal to c times x times z over x squared plus y squared plus z squared when
The bottom quantity is greater than or equal to 1, but less than or equal to 4.
okay, so everything, the point x, y, z has to live inside the sphere of radius 2, but outside the sphere of radius 1. It's like two balls like sitting on top of each other. It lives in between them.
Oh, okay, that's weird, but alright.
Like a jawbreaker section.
Yeah, that's yes. Okay, so we just have to verify that this works for part A.
Okay.
So the solid E is given by this guy.
You love food here. We love food here.
Yeah, that's right. Everything's
Everything is food related.
Yeah.
So that'll give the bounds over the triple integral.
Yeah. However we choose to bound that solid will give us the bounds of the triple integral. Spoiler alert: it's a sphere, so he's spherical. In fact.
That'll give you rho.
Yeah, in fact,
Squared?
x squared plus y squared plus z squared is rho squared. So, I mean, automatically you know your bounds for rho.
And then from there you just determine.
How much of the sphere do you want? I mean, do you want like,
You want that quarter.
yeah, is it in the
First quadrant.
octant, or is it in the, where else is
This
it?
is the first quadrant.
In the first octant.
Okay, so this is,
Octant, excuse me.
so if you're thinking in terms of a picture, that just means it's in the
That.
octant where everything's positive. It's the one like right in front of us. So it looks something like this.
Okay. Oh, not me.
Not me either. I think it's got something to do with practice.
Yeah.
I actually made a pretty elaborate drawing yesterday. I was pretty proud of it.
We're good. So we want the portion that's inside the bigger of the two spheres, but outside the smaller of the two.
That jawbreaker section.
Yeah, I like that. I haven't thought about those since like 15 years.
Those things are huge. Sorry.
Alright, so we just have to figure out the bounds on phi and theta. So theta is this guy.
Which is a 90 degree.
Yeah, pretty good.
Oh,
And then phi is this guy where we rotate the z-axis still.
90 degrees. And then that's from zero, same 0 to pi over 2.
And phi's the the z-axis when we rotate it down and hit our surface.
I'm
Since we,
still really bad at that.
yeah, that one's tricky.
It is.
So
I always have to think about like myself as personally being the z-axis when I think about how far I rotate it down, because you know, like I lift my arm up and that's at 0 degrees for phi. If I point it straight out, then that's 90 degrees for phi, and if I go all the way down, that's 180 degrees for phi. I like to think about it that way. So if my shoulder's like
The
the
origin.
origin,
Yeah.
then I'm pointing it all the way down until I'm right on the XY plane, and then the surface like ceases. So I go from 0 all the way down to
2 pi. Pi over 2.
yeah, there you go, to 90 degrees or pi over 2.
So this gets kind of tricky, if I recall correctly, and this isn't this particular scenario, but whenever you were first explaining this and you were talking about how to get that full sphere, like,
Yeah.
and like the typical bounds would be like theta bounded from 0 to pi, no, 0 to 2 pi, and then phi from 0 to pi,
Mhm.
right? So, just like briefly, could you like explain that the way that they like? I understand that rho is like just the distance from the origin, but then so theta's this one, right?
Yeah, it's the angle we rotate the x-axis
Okay.
through.
So that would make sense that it would go like make the full rotation around the circle.
Mm-hmm.
So then, but what was the reasoning again? It wasn't that phi didn't go like all that phi didn't make like the full
Because you'd
Yeah,
be double.
full trip around. Like,
So, do you know, like, sometimes if you get like cheesy